Okay, let's jump right into a software demo of editing geographic data in ArcGIS. As you'll see here, I've got an untitled map document, and it's got a few data frames in it, but we're going to start working down here in this new data frame 2, and I'm going to rename it Demo Editing. How about Editing Demo? Just to distinguish it from the others. I did this demo in class earlier, and so there's some layers in some of these other data frames I may pull from. But for now, I'm going to pull out of this abtech_all_1 geodatabase, and I've got a couple of different layers in here. This roads lots poly does a pretty good job of showing the roads that go through AB Tech and some of the parking lots as well, essentially the asphalt roads, parking lots. The roads kind of go right through parking lots from one parking lot to another, so it's kind of hard to distinguish between the roads and the parking lots, so we put them all in one layer and for this representation. And in addition to that layer, I'm kind of curious about some of the sewer line and manhole information that I've got in this map, so I'm just going to drag it down here. So now we've got that's the streams or the pipes. There it is. All right, so I've got some different data layers in here now, and I'm going to symbolize them so you can see what they look like a little bit. Maybe make the streams a blue. All right, so we're starting to better represent our data here. And in addition, I think it would be nice to have a base map showing of the aerial photography. So I'm going to use the Esri base maps to make it kind of quick and easy and add the imagery with the labels. This base map will be streamed online, so it could take a little bit to draw. But as we start to zoom in and look around, you'll start to get a better feel of what this area looks like with our campus and some of the vector layers that we have displayed on top of it. It looks like the computer's caught in a little bit of a processing loop. So let's just give it a second here. Hopefully this doesn't cause a big problem in my demo here. And it looks like it may. All right, so I'm not sure what was going on there, but I'm glad we didn't have to restart things. So here we are looking around at the campus here, and the first thing I want to make mention of is the aerial photographs. And when you're using aerial photographs as a base layer or a reference layer for what you're updating or creating, it's important to understand the year of the aerial photos or the date of the aerial photos. So in this case, you can usually look down here to get some credits for the surface layers, and you'll see it doesn't show you real readily the exact year, but it gives you some information on where some of this data came from. When you stream in a worldwide imagery service from someone like Esri, the data is tiled for different scales and different locations. They mash together aerial imagery from a tremendous amount of sources. So in this case, as you zoom in, notice that it'll go from imagery taken with leaf on in the forest to all of a sudden you'll see a different, it's still leaf on, but you can tell it's a different image, right? Came from a different place, a different source. So I'm going to make our roads lots polygon. a little bit transparent so we can see through it a little bit. And notice here, there's tennis courts right there. Those tennis courts aren't there anymore. There's a parking deck, and this parking lot is not there anymore. There's our conference center is there, and this parking lot's changed. So as we keep zooming in, notice their highest resolution at the best scale data from Esri doesn't have updated data for that area. So what I'm going to do is I'm going to add data from our state GIS department. It's the Center for Geographic Information and Analysis. NC1 map is where they store their data. And so in addition to adding base maps, I can also just go to add data, and notice under the add data I can add these things down here, and I can add GIS servers. Now when I went and add data from a base map, it's loading data from a GIS server, but it's built into ArcMap to load data from their own GIS servers. I want to load some from a WMS server, and if you know the URL, which I can provide to you, or you can look it up on NC1 Maps webpage. If you know the URL, the webpage address, you can consume data from their servers, as long as they make it publicly available. And they do, and it's this right here. And so it's their imagery latest cached layer, and as I load it, it's going to project on the fly, but watch what happens right here. Newer data, right? So if you look at something like Google Maps, you'll even see different data for that area. It's even more up to date than the statewide imagery. So let's look at the satellite. Google has the most up-to-date stuff. Google Maps, by the way, is really awesome in their 3D rendering these days. If you notice this building right here, see that side of that building? Look at that. See how it does that? Google Maps has gotten really, really good at how they represent data. This is not even Google Earth. This is just Google Maps. You can't get their imagery and consume it. They don't provide it like other people, but they've got their own satellites now, and so they've really got great data. But this is good enough to get the new orientation of the parking lots and the new buildings. You can still enough to get that off of. So let's just look at this a little bit and try to look at how we want to represent some of this stuff. So a lot of this has already been updated. I'm trying to find something that I can update while we talk about this data. Alright, so there's this parking lot back here. This is an actual parking lot now. And so it's not the best representation of the parking lot yet, but in a pinch, it's good enough to sketch in where that parking lot is. You know, it's not going to give us the exact location of the curbs, but for now, to update our database, it's worth doing. So I want to update this roads lots layer. Let's remember that data can be loaded from many different sources into our map. So, for instance, we've got data loaded from the Asheville geodatabase, the streams layer. We have data loaded from a shapefiles folder, these two shapefiles. And we have data loaded from our AB Tech geodatabase. So from what we said earlier, if I start editing, it should ask us whether we want to edit in this database, or in that database, or in that folder. And as I click one of these, it shows you the layers with a little pencil that you are able to edit. So in this case, I want to edit the roads, lots, poly. You see the little pencil there? I've picked the right database. I click OK. And typically, the Create Features window should pop up. Because I've had this map document up, it didn't. If it doesn't come up, you can go to your editor drop-down. Notice that my editing tools have lit up now. They're not grayed out anymore. And I can look at my editing windows and make sure my Create Features window is open. This is my feature template. It describes the symbol that's going to be used. It points to the layer in the database, and it also gives me some tools that I can use to create features. So, if I need to add on to this, there's some different things we could do. With our edit tool, if I select a feature, if I double click it, I see the vertices. So, this is not the best way to do this, but I could. Whoops, I didn't mean to do that. Control Z will undo that operation. Oh, that's it's a curve. That's why it's doing weird things there. So in this case, what I think I'll do is add a polygon, but I need that polygon to be adjacent to this polygon. So I could just make sure and hit those two vertices, but since there's a curve in between it, it's going to be hard to recreate this line exactly to make an adjacent polygon. So these moving these vertices aren't really working either. So what I'm going to do is I'm going to use my reshape feature tool. And I'm going to click that, and then I'm going to choose my straight edge segment and click there, and I'm going to reshape this polygon. Again, I'm not being perfect, and since this, and I'm going to change right in the middle to this curve tool. Make a nice curve there. And I'll curve that one too. So that reshaped that feature instead of moving individual vertices. Oftentimes, you want a polygon to be adjacent to another polygon instead of reshaping, and we'll look at that using the autocomplete tool coming up soon. So that just updated my parking lots layer to show this new parking lot. Okay, so editor, save edits to save my edits. I don't have to update the attributes for this layer. There's not really attributes in this particular layer. It's just a big layer that shows all of the parking lot roads for the whole campus. All right, so now let's say that that we want to build a buildings layer also. So let's just say we don't have a buildings layer for this particular for our campus here. So you can see the buildings there on the photo. So why don't we digitize in some buildings? I'm going to stop editing because in this case we're going to imagine that I don't have a buildings feature class to digitize on yet. So in my AB Tech All Geo database, I'm going to make a new feature class by right-clicking the database and making a new feature class. So the first example, we were updating some existing data for parking lots and roads. In this case, we want to create a new buildings layer, and we don't have a buildings layer. So we need to create the buildings layer first, and then we need to add the features to it. So this is the process. You right-click the geodatabase that you want the new feature class or layer to go into, and you say New Feature Class. It requests a name. I'm going to call it Building. How about Campus Building? How about Campus Building Demo? Just so I can keep up with what I'm doing here. You have to pick the type of geometry that will be stored. Point line or polygon are commonly what we use. Note that there is a default feature type in here. In this case, buildings are going to be polygons. So not changing this is fine. It's got the right thing in there. Every semester, I see a student who creates something that should be a point feature class, but they don't go in here and tell it point, and so it ends up as a polygon. You can't change that after the fact. Okay, so make sure to pick the appropriate geometry type here. From there, you need to pick a spatial reference. Now, we know that this data is being displayed in state plane coordinates because the first feature class I loaded in this map was the roads, lots, poly that are in state plane. So that's our reference layer, and therefore the coordinates that our data will be created in. Therefore, our new layer will be in the same. I could just go pick state plane out of the list, but since I know this is truly what the coordinates are because that was the first layer loaded, instead of picking projected state plane NAD 83, I'm going to import from the layer that I used to load this in from. And it was this layer right here. So it takes on that same spatial reference. Thinking about the spatial reference is important. We're going to take the default XY tolerance. This is that cluster tolerance I mentioned. This, among other things, defines which features are considered coincident based on them being within the cluster tolerance. The next page has to do with data that are stored in an enterprise-wide geodatabase system. It does not apply to file geodatabases or personal geodatabases. So I'm going to click next to that. Just take the default for that one. Now we get the opportunity to define what fields you can input attributes for in the buildings layer. Now, when you go to do something like this, you should have thought through and designed your GIS database, and you should have a good idea of the types of attributes you want to collect. In this case, we'd like to collect the building name. Every building has a name. And every attribute field, you choose a type of data to be stored. This is normal database concepts here as far as data types go. All databases, you can store data types. The first two are integers. Integers are whole numbers. If you need to store 1, 2, 3, 4, you'd use either a short integer or a long integer. The difference between short integer and long integer is the amount of significant digits that can be stored in that particular data type. Short integers can store 32,000, over 32,000, just over 32,000 significant digits. When you get above that, you need to have not significant digits. 32,000 is the number. The significant digits is 7. Or 5, I'm sorry. 5. So, short integer for 5 digits up to 32,000. Long integer for bigger. Float and double are the same except for they can hold decimal places. Or floating point numbers. They can hold decimal places. Float cannot store as many as double. Then you can store text, you can store dates, and you can store some other advanced kind of data types like binary large objects or blobs, things like videos, rasters like a picture of a house, something like that. So you got to pick you got to put in the attribute fields and their types. We're just going to do text fields for these. So then I'm going to click Finish. By default, it adds it to the database, or adds it to the map. It puts it in the database and by default adds it to the map. And now if I start editing that database, I have the option to edit the buildings or the roads and lots. So I'm going to click OK. And if I make sure my Create Features window is open, I can make polygons to digitize in things like these buildings. I'm left clicking everywhere I put a vertex. Is that good enough? I should probably be zoomed in a little bit more to get a better representation for class demo. That's quick and easy. I don't know if that's quite good enough, but it comes in selected. I can open the attribute dialogues box here, and I can enter in the attributes. That is the Balsam Computer Technology Center. Okay. Something else I neglected to show you, if we look at the attribute table here, and if we look at the properties of that field, the field type has values. Make sure that you include a long enough length for all the possible values you want to put in there. Balsam Computer Technology Center is probably getting up there close to 50. Okay, you can't put more than 50 in that one. If you were storing the state abbreviation in this field, North Carolina, South Carolina, Georgia, Tennessee, all you'd need is a length of 2. So consider the values that will be put in there. Again, that's just a database concept there. More than GIS, that's a database concept. Okay, so that put in that field. So if let's just say that this building had this part added to it after we digitized it, just that little thing, that's really just an overhang. But if you wanted to add that to this layer, you could double click it. I could insert a vertex there, insert a vertex there, if I can right click in the right place. You can move that there and that there. That didn't really quite do it, did it? I need another vertex. So you can see inserting vertices and moving them around works, but the bigger edits you make, the more it makes sense to just modify the feature by using this tool, Reshape Feature tool, in conjunction with some of these other tools. Okay? All right. So moving right along. That's creating new features and updating attributes. Your tools, well, you've got a toolbar with your editor toolbar here. These tools, whether you're doing a straight segment, a curved segment, or tracing a line or polygon, we'll see they work in conjunction with your Create Features tools here and your feature templates. So these all kind of work together. So I'm going to stop editing and save my edits. And let's move on and look at some more examples. So for now, we're going to add a parcel layer to this feature, to this map. I'll actually do it from over here. These are the parcels for around campus. And I want to show you a technique for splitting parcels. So I'm going to make this parcel layer where I can see through it a little bit. Make it transparent. And let's look down here. Where was the example I wanted to use? Over here. Okay, so if you wanted to update this parcel layer, and let's just say not even use it as a school example. Let's say that you owned this property right here, and you wanted to sell off this piece of land on this side of this stream. So you wanted to subdivide or split out this polygon, this area on this side, based on the location of the stream. And out there on the ground, the stream actually is the location that marks the difference in the two polygons. Instead of going to editor and start editing and picking out the database that has the layer in it, you can also right click a layer in the table of contents and go to edit features and start editing. This way it doesn't make you choose the database. It knows you want to use one of these it knows the database you want to choose based on where you right clicked and started editing. And here it is. My toolbar's lit up and ready to be used. If I select that polygon, I can cut polygons to cut it in two pieces. And so you can start outside or snap to the edge of it. I'm just going to start outside there, and I know this stream is what I'm supposed to be using. Okay, and I can do a pretty good job of snapping to it as I go. I mean, the snap tool works pretty good, but that stream has a lot of vertices in it. You're never going to hit every one of them. And whereas that looks pretty good, yeah, I followed it pretty good. They told me it's going to split it over to that corner property right there. When I double click that, notice it split it in two polygons. And it did a pretty good job unless you really zoom in and look, and you start to see some little differences in the where the data was split and that stream. Can y'all see that difference there? And it kind of overlaps the other way this way, and you'll see data built like that all the time. Okay, but a better way to do it, I'm going to Control Z to undo that, and I'm going to throw the streams on top of the parcels so we can see them better. I'm going to turn off my imagery so things will draw a lot faster. And I've got this selected polygon. There's a great tool called the Trace tool, and so what I'm going to do is I'm going to cut polygon. I'm going to start right there, and then I'm going to tell it to trace this line. It's going to go down that line, and it's going to recreate every vertex along that line. And then I'm going to switch back to my line tool and go over there and double click, and that actually used the stream to split the polygon. Okay, now when you do that, you got to decide if that streams layer is accurate enough and if that's what you want to do. But it's better to have things that's kind of builds into this vertical integrity into the data, and it builds in a method of keeping your data built in a way that's more topologically correct. All right, so now we've got these two polygons, and let's look at a topology tool now. All right, so we're just doing regular edits here, and let's look at how the lines between two polygons are handled during a regular edit session. Remember, this line right here is part of the definition of this polygon and that one. So if I double click this and I move this vertex, creates a gap. Those lines are coincident. I'm going to click Control Z, and I'm going to bring up my topology toolbar here, and I'm going to create a map topology. I can't create a geodatabase topology because I don't have a geodatabase topology. But for the parcels layer, I'm going to say anything within the cluster tolerance of 0.003 thousandths and change feet are considered coincidence. When I click OK, now with the topology edit tool, this is how I select features in a topology. If I double click that line, it shows me the coincident vertices, and if I move one, it's going to move them both. So it moves two things at once. I'll just show it to you again here. Okay, so it handles that coincident line between them because they're coincident. It's within that map, that cluster tolerance, as part of the map topology and the topology cache that was created. So I'm going to stop editing here, and I'm not going to save my edits for now. But I want to show you the same example with the pipes and the structures. I'm going to start editing the structures here. Now, the structures are essentially manholes, okay? And if you look at this example, see how these manholes are on the ends of these lines. Now, if I just start editing, or if they call me up and they say, hey, we moved that manhole, you need to move it in the database. Maybe they gave me a set of coordinates for where they moved it to. Let's put that above that. I could right-click it, and I could move it to a set of coordinates if they told me the coordinates, and it would move right over. I could also just grab it and move it. Now, I moved it over there, right? But the sewer lines didn't move. You can bet if the sewer department went out there and moved a manhole, they're going to move the lines to it too. So you could double-click this, grab the endpoint, move it, snap it to it, same to this, move it, snap it to it. But that's a lot of edits. Instead of doing that, we could create a map topology between two different layers, in this case shape files. It will build a topology cache within that cluster tolerance, and now instead of using my regular edit tool, I use the edit tool on my topology toolbar, and you can barely see it. It selects it as this fuchsia color. The pointers look a little different, but now if I move it, it moves coincident features with it. It allows you to manage coincident features during an edit session. The selection is this kind of fuchsia instead of what a selection looks like outside of an edit session or outside of a topology and all that. So that's a little bit more on map topology and using it to manage coincident features. All right, I want to show you a couple of other tools, and then we'll wrap up this demo. Let's insert, or let's activate this data frame and look at it here. All right, so here's some data from the city of Asheville, downloaded right from the Buncombe County website. Okay, now if I want to edit this data and I go to start editing, why is that grayed out? I'm still editing in the other data frame. So I've switched data frames and I forgot I was still editing in this data frame, so I need to stop editing here. I'm not going to save my edits just since we're demoing. I'm going to go back to this data frame and activate it. And since we were talking about building data that has this vertical integration of layers and lines that are built correctly, I'd like to show this data set as an example. This is the municipalities layer and the Buncombe County boundary layer. And this is Montreat here. And this is McDowell County here. And this is Buncombe County. Does that look right to you? Does that look discerning or concerning, or does that look right? Nah. Montreat, the boundary of Montreat is Buncombe County boundary. They are the same. I mean, there are two different layers, but they're the same. So this data, it would be better if it were built in a way where the boundaries matched. To further complicate it, the grandfather ranger district boundary goes right down that line too. So if you loaded the Forest Service ranger district's boundary, you'd see it's different too. This municipalities layer and this county's layer and the Forest Service ranger district's boundary layer were created by different organizations, by different people in those organizations, using different methods in different years. So you end up seeing data like this often that is not built quite perfectly to be integrated together because it wasn't built to be integrated together. It was built by different people for different reasons at different times. When you can, you should strive to build your data better than this. You can't go through and fix every layer like this in the world, but you should understand why and how it got like this, and if it makes sense in your given project to fix something like that, you should. This would be pretty easy to fix. I can select that one and I can reshape it. Start there, go straight across to here, and then start tracing down this line. Clicking occasionally to make sure you don't have to click, but just to make sure. Now that started following the wrong line. Alright. Now I'll draw a straight line segment over to there, double click, and they match. They're the exact same now. That is assuming that the Buncombe County boundary is better, more accurate than the municipality's boundary, and that's a consideration to be made. But you can change that data if you need. If you were making a map of Black Mountain and Montreat and you were showing the county boundary and the municipality boundary, that error would be obvious in most maps at most scales of that little area. Some maps you're just not even going to notice it, depending on the scale and stuff you're mapping at. Again, you can't fix all data, but that's the kind of thing you should strive to do when you're building your own data. And you strive to make stuff match the best data that you have. So that's another small example I wanted to show. As one more example, I like to show the autocomplete polygon tool. So if Black Mountain here, if they added on a bunch of property right here, how would you add a polygon that is adjacent to this particular polygon? Well, if I went to municipalities and I created a new polygon, and I zoomed into here, I could try to snap to every vertex in here. I think I missed one. It's hard to say. Boom. Yeah, that's a pretty good job, right? You can do a pretty good job on ones that don't have a ton of vertices, but you want to do better than a pretty good job. Another way to accomplish that would be to trace that line, and that hits them all. Okay? Even a better way, and a tool that they created just for that, is the autocomplete polygon tool. It allows you to start at one place in a polygon, build another, and then double click there and it automatically rebuilds this coincident line. So there are tools that help you to maintain these coincidents even outside of a topology kind of environment. That's not really a topology tool, it's just an edit tool, but it automatically builds that adjacent the coincident line between adjacent polygons. So those are just some tools. The editing environment is very powerful, very robust. There are a tremendous amount of editing tools. You get good at it by using them a lot. Make sure to save edits often. The worst thing you can do is edit for 2 hours and then your machine crashes and you lose 2 hours of edits. So make sure and save your edits often. That is different than saving your map documents. And that's what I have for the editing demo today.